Hello, everybody. Welcome to GOTO Book Club. My name is Polak. I'm the Vice President of Developer Experience in Treeverse, which actually means I'm getting paid for working on open source. So this is great fun. And together with me, I have Holden Karau. Hi, Holden.
Hey, I'm Holden. This is Professor Timbit. He's going to be making sure nothing sneaks up on us while we're doing our important discussions. I work at Netflix. I also get paid to work on open source. I enjoy that. I'm very fortunate to have been paid to work on open source for the past 7 years. I do feel very, very fortunate to have that life. And I guess we're talking about the Kubeflow book that I co-wrote with some really awesome folks.
Yeah, today is going to be packed with a lot of good stuff. Writing books. Where should we start? Like, what inspired you to write the Kubeflow book?
That's a great question. I don't remember, honestly, because while I was writing the Kubeflow book, I actually also got hit by a car, and so my memory is a little fuzzy. Because take a bunch of opiates when you break both of your wrists. So I don't remember what inspired me to do it. I think, honestly, probably part of it was I was dating someone who worked on Kubernetes, and I was like, Kubernetes is fun. And also I was working at Google at the time. I really like Kubernetes. I like machine learning. And I really wanted to see if we would get better tools for sort of integrating data preparation with the rest of the machine learning space. And I was hopeful that Kubeflow pipelines would be a really good way of doing that. One of the people that I worked with from the Spark community had been working on Kubeflow serving over at Bloomberg as well. So that was kind of like, okay, cool. Let's write a book on this.
Yeah, it sounds like a lot of fun. Like, one of the great perks, I think, of working on open source is you get to collaborate with a lot of people from different companies.
Yeah.
Yeah. So you get to learn about other people, infrastructure, tooling, what they care about, etc. So going back into Kubeflow, you mentioned it's a combination between the Kubernetes world and serving machine learning.
Yeah.
How does it work?
Oh, that's legit. So underneath the hood, it's changed several times how it actively functions, but in practice, I would say the core of Kubeflow, or at least the design principle of Kubeflow, is to bring together the different tools that people would commonly use for machine learning and try and provide a partially unified interface for putting these different tools together so that you can use them in pipelines, and you don't end up having to have separate deployments to keep track of everything. So the idea is everything kind of gets deployed together. You can make a pipeline that's going to use the different components inside of Kubeflow, and there's also metadata tracking. And there's also an experimentation framework. And there's all of these other things that are then built on top of the fact that all of these tools live together inside of the same sort of pipeline experience. Underneath the hood, how it actually works has changed at least 3 times, probably more. But ideally, you shouldn't have to know that too much, right? The exact detail of how they're stringing everything together shouldn't matter too much. Early versions of Kubeflow pipelines did everything by passing volumes between the different pods, and that's a little not great. And then they realized this isn't great, and so they changed how the data flows around a little bit to make it a little bit more scalable. But, generally, you hopefully shouldn't have to notice.
Interesting. It really takes me into like training machine learning over a large set of data. So
Yeah.
is that something that Kubeflow supports?
Sort of, I would say. The answer is sort of. And I have obtained the professor. He is going to explain to us how Kubeflow sort of trains large machine learning. So Kubeflow has a few different ways of doing data preparation and a few different ways of doing model training. If you go sort of like with the everything is a volume path, then you're naturally limited to what volumes are. But Kubeflow can also work with object stores, which is much better for scalability. And you can do your data preparation with Spark. You can do it with the other tool that I worked on, which I should remember because I worked on it for like a year. How do I not remember something that I worked on for a year? It's like Flume Java internally at Google, externally Beam. Yeah. So you can use Beam to do your data preparation. And then for the actual like model training, you can use all kinds of different things. And it can do parallel model training. And you know, it works pretty well. There are some limitations, I would say. So some of the tooling inside of Kubeflow doesn't scale, and other parts do. And it's not always super clear, I would say, which parts are scalable and which parts are not, which is an area with opportunity for improvement. We could say if we were writing a American style performance review.
Interesting. So when designing the book and thinking about, table of content, usages, etc., how did you refer to the different areas where where Kubeflow scales well, and where it kind of there's a room for improvement?
Yeah, that's legit. So for the table of contents, we didn't really go that way. We sort of just went into the traditional, like, hey, this is the first thing that you're going to do, right? You're going to do your data preparation, your data cleaning. And then after that, you're going to want to like do some kind of model training, and you're going to like want to also like use cross-validation tools. And so it was very much like, this is probably, we tried to lay it out in sort of the journey of building something. Of course, we started with a like teaser chapter, as it were, which used completely non-scalable tools, but you actually got something working quickly, because otherwise, like, you're not going to read 200 pages of text to hopefully train a model. You want to like have something with you early on. So chapter 2, I think, was just like, hey, look, this works, we promise. And then the next like X chapters were very much like, okay, cool. So now let's talk about how you're actually going to do this. And then, so each chapter we talked about the different tools that you could use inside of Kubeflow. And we talked about which ones were scalable and which ones weren't inside of each chapter. So you could decide, essentially, if you were working with small data sets, your life was a lot easier, and you could go down the essentially like the faster path to happiness and success. And if you're working with large data sets, then you probably got better models out of it, but there's a reason why we get paid to do this stuff.
Yeah.
Yeah.
I think the conclusion of there's a reason why we get paid to do these things, it's a very strong statement.
Yeah. It's fun. It's fun, but it's also like there are times when I just wanted to like poke my eyes out with a rusty spoon, and go live on a farm somewhere. I mean, I have no skills. I would die immediately. Well, maybe like 72 hours, but like for example, some of the data preparation tools were just like, oh God, what is going on here? But it's okay. It's okay, right? Like if it was too easy, we wouldn't need a book about it, and I wouldn't have a job. That would be very sad because I live in America, and if I don't have a job, I don't have health insurance. And if I don't have health insurance, I die. So the fact that machine learning is hard keeps me alive.
Yes. Fabulous. Let's continue, that path. It's always struck me. There are people that studies machine learning or data scientists, and then when they actually find a job and they start working in the field, they realize that it's tough. It's more than having already made up data sets from Kaggle, where it's all fun and nice. I was actually, so I'm writing a book about Spark and machine learning. Yes, thank you so much.
I'm so excited for your book. It's going to be awesome. It's going to be so cool.
Thank you. I really hope so. There's a lot of good stuff into it, and it kind of really speaks on the verge of like machine learning without touching a lot of the machine, like what is machine learning? So assuming people already know that, and then diving into distributed architecture, graphs, scheduling, and all this good stuff. And actually, one of the areas discuss the distributed TensorFlow approach and Keras. And Keras API actually provides that data set out of the box. So one of the things I wrote there, I said, it provides data set out of the box, which means you don't have to pre-process it, which is awesome for learning, but doesn't really happen in real life.
Yeah, in the real world, no one comes to us and it's like, here is some wonderful data. It's super clean. There's definitely no invalid values. All of the columns are as labeled. I know what the schema is. It's great. No, everything's terrible. But that's okay, right? And I think one of the things that I think about when I think back to university is like, there's that thing where we learn maybe how things should be or how things could be. And then when we come to the real world, we discover that, everything's terrible. And we can make it like things should be, but it's going to take a lot of work. But we'll get there, right? Like we can get to the idealized clean data set. It's just, it's going to be several months of work. I think that the space of distributed training, right, is still something that is super open, right? Like we can use Kubeflow to do our scheduling. We can even just use Spark. We can use Dask. There's all kinds of different tools that we can use to do our data preparation and then do our model training. And there's no clear one right way to do things yet. And I think that's kind of neat, right? And I hope that we do what we did in the big data space, where we all steal the good ideas from each other. And then eventually it doesn't really matter which tool you're using because they're all like close enough, right? It's not stealing when it's open source. It's, I don't know what the fancy word is, but collaborate effectively. I'm optimistic. Yeah, borrowing.
Borrowing the concepts. Yeah, 100%. Like now we see the world of big data evolves. I think at some point there was a lot of news about the fact that big data has died.
Okay, cool.
Yeah, still to the people who makes money out of working in the field. But I think it's just being transformed, and a little bit of what I feel in the moment that we're kind of living in a cycle of machine learning was very big at some point, and then we introduced more data tools to handle machine learning, and we realized that, hey, it's great for machine learning, it's also great for analytics, right? So we can build a lot of this cool analytics stuff because for machine learning, it's maybe not ready yet. And then we get another circle of machine learning, and now I believe machine learning and data love, I like to call it. But now we're actually in the phase where we're discussing data again, right? Metadata, pre-processing, all this good stuff. And that brings me to your to the books that you're writing now, actually.
Of course. And my publisher would be very annoyed with me if I did not mention the books that I was writing right now. So one of them is scaling Python with Dask. The other one is scaling Python with Ray. Very similar concepts. And the other one that I'm most excited about, and I don't have a publisher for yet. So if you publish kids' books and think that this says children's author, you give me a call. More likely, it'll end up being self-published, but that is distributed computing for kids. And that one is less machine learning. That's more just like, hey, what's up? I think that functional programming is super cool. And I think that if we don't call it functional programming, we can teach children functional programming. And I think it'll be really awesome. And it tries to teach functional programming and distributed computing through garden gnomes and Spark. We'll see if it's a success or not. But yeah. Okay, sorry, my brain jumps around a bunch. There's like a whole bunch of different cool things happening, right? Like, so Ray has, both Ray and Dask use Apache Arrow pretty extensively. And Spark also has Apache Arrow, and TensorFlow, you can feed Apache Arrow stuff to it as well, right? And it's like, so I'm really excited that it looks like we're actually finally agreeing on a data format for interchange that isn't CSV. So that's really cool, especially because we can pass these objects around in shared memory. It's like super painful to do from Java because Java doesn't really like it when you're working with, raw memory buffers, but we can finally do it. And it's really exciting. And the other thing that I'm really stoked about is like that one of the things that I remember people were so excited when Spark added their data frame APIs. They're like, oh my God, I get distributed data frames. And I was just like, well, you get something that we call distributed data frames, but like you really need to temper your expectations because I know what you're thinking of, and this is not that. At all, right? And then they're like, oh, I don't get distributed data frames, do I? And I'm like, yeah. The cake was a lie. Sorry, I'm old. But the nice thing about Dask is we finally have distributed data frames. And because Dask has a really good distributed data frame API that's based on pandas, Spark was like, oh, wow, okay, we need to catch up. And is also adding a distributed data frame API based on pandas. And this is super great for machine learning because like if you're working in one of these like places or you're going to school, right, you probably did a lot of your data like munging and preparation with pandas because like it works fine on Kaggle sized data sets. But then you come to the real world and you're like, oh crap, now I have to use these other like super janky tools. And it's like, no, it's cool. We like put a fine layer of paint on top. And now you can pretend that the 6 cats underneath is actually just one panda, right? The metaphor is a little fuzzy, but it's exciting because like I view it as we are reducing the amount that people have to know, the cognitive load essentially, in the way of people getting to accomplishing their tasks. So I'm excited that we're making the tools look more familiar. Unfortunately on the downside, like people aren't really going to buy a book about, actually they might. Maybe people would buy a book about distributed pandas. But I think that even while we're making the APIs look a lot similar, and function very similar, the performance is different enough that unfortunately the abstraction is a little bit leaky, and there will be sometimes you realize that your panda is actually 6 cats and a hamster. And then you'll be like, oh, damn it. But that's okay, because you won't always have to think of the 6 cats and hamster together.
Yeah.
Sorry.
No, it's a great analogy. It reminds me of the YouTube video of herding cats. Do you know it? When you try to kind of schedule everyone to be in the same place and work together nicely, to pose for to pose nicely and work together. So
I had a very brief stint as a program manager, and that was where I was like, I'm a professional cat herder and I hate it. So big shout out to program managers out there. Thank you for herding the cats. I cannot do it. I can only herd the computer cats because they're at least semi-deterministic. The human cats are just like 100 times worse.
Yeah. Well, they're doing a fantastic job. Everyone who's doing program managing, definitely a tough task. Well, thinking back about the abstractions and kind of providing interface on top of that, distributed systems and distributed computation in a way that is, the experience is good, people understand it, people have a previous experience with a similar API sometimes can help. And that actually brings me into Ray and Dask. How is their API in usage when you, for example, compare it to what exists in Spark today?
So there's certainly some similarities, but there are also some really big differences. So Ray and Dask feel more similar to Spark for me than I think they will for most people, because one of the things that Ray and Dask do is they expose lower level APIs which exist inside of Spark but are not exposed externally, right? So there's like these internal task APIs, and we do various things around how we handle task retries and stuff like that. But Ray and Dask just also directly expose those APIs to users, right? And this has ups and downs, right? On one hand, it means that when people go to use those APIs, there is this sort of like additional, like, what's going on here that you have to have this extra mental model around. On the other hand, one of the really cool things I think we've seen that's been possible because of that is there is a much healthier library ecosystem, because the library authors are able to take advantage of like certain lower level properties that they weren't able to when they were building on top of Spark. So that's pretty cool. API wise, so Ray has a rapidly evolving data API, I would say, but it's still pretty bad. It still has a lot of room for growth. For example, you could not use the Ray Data API to do word count until I think this year, possibly late last year. And like that's a pretty basic problem, right? And that's okay, because fundamentally, like, the Ray's model is more focused around enabling you to use other tools on top of it, I would say, right? Like, it's very focused on exposing fast conversions to Spark, to Dask, to other tools, to make it so that you can take your data in and out of Ray essentially for almost free, and then you can have a really nice experience. On the other hand, like, the data APIs that are inside of Ray itself, if you come to it from something like Spark, you're going to be sad. With Dask, I would say it's interesting. They have 3 different types of collections, right? And Dask Bag is similar to Spark RDD. Dask Data Frame is similar to Spark Data Frame, but also more similar to Pandas Data Frame. And then Dask Array is sort of not similar to either of these things, but similar to NumPy arrays, but distributed. I think there's some places where people are going to be like, what's going on is with partitioning, with query pushdown and metadata interfaces. And the optimizations just aren't there, right? And that's okay, because they're generally a little bit lighter weight in terms of their implementation. This is a pretty common pattern, but like there is no automatic filter pushdown in either of these systems, right? Like that is up to you to push down your filters by hand.
Interesting. There's a way to go, but maybe on the other side, they might have better support for Arrow. I think I've seen. Yeah.
Yeah. I would just say Dask and Ray both do better jobs of integrating tools outside of themselves, right? Dask and Ray both make it easier to work with other machine learning tools than you would necessarily get from inside of Spark, right? Like it's definitely a little bit more painful to do that inside of the Spark ecosystem.
It's a really interesting approach to open source. I know there is the Pluggable architecture, which is an architecture that enables that collaboration. And you probably know it better than I do, but I don't think I've seen it in Spark.
No, Spark is not really happy about pluggability. Every time we try and make something new pluggable in Spark, it's a battle. I think part of that is from just the culture of the project. And yeah, Dask and Ray are very much more modular and like, yeah, whatever, you can swap your components around. That's fine. That's normal. I think they were forced to do that because they came onto the scene a little bit later. And so they couldn't do everything all at once, right? They couldn't boil the ocean. So it was very much like, yeah, whatever. These are the parts we provide and you bring the rest.
Yeah, interesting. From what I've seen, it gave light to a lot of other tools in the ecosystem as well to see how they can kind of work together along with Spark and provide these better ecosystem for building data pipeline, for building machine learning pipelines, and everything that comes together. I think the further we go, the more different connectors and different tooling that enables to connect with things such as Spark. And I think I was writing a whole chapter about Petastorm specifically in order to bridge from Spark to frameworks such as TensorFlow and PyTorch and enable the two to coexist, which I think is really interesting in how they did it and how they enable actually, how they build it is basically Petastorm is a framework to read Parquet files, which wasn't exist out of the box in TensorFlow and PyTorch. And with Spark, we know the Parquet files are actually the default or kind of also the best practices for saving data. And so we kind of omit the CSV option. I'm just going to push it out of the way. But going back to your books, I think this is exciting. So how do you organize your schedule to be able to write 3 books in parallel and also have a full-time job and take care of Professor, of course?
Oh yeah, Professor Timbit is very important. So there's a bunch of different things that I do. So distributed computing for kids, like that's a very slower project. It's sort of a long-term project. And actually, the illustrator who I'm working with is she's from Ukraine, so it's on hold right now. And hugs and support to everyone dealing with the terrible shit coming out of Russia right now. I'm so sorry. Anyways, sorry, that detour. Schedules. So definitely like there's prioritization, right? There's like, I need to do my job because I like not, getting evicted. It's nice having a place to live. So that takes priority. The Dask and Ray book, I try and set aside a little bit of time each week to work on them. Part of how the Ray book progresses faster is that I have a co-author who he's really motivated to get it done quickly. And so we have a sync every Friday, and I definitely am just like, oh God, I need to get something done for Friday. Okay. So Thursday night, I'm often like, okay, let's do some writing. And the Dask book, I don't have that same pressure. So the Ray book, I would say like draft wise, we're up to like, I want to say chapter 7, and the Dask book draft wise, I'm up to chapter 3. And that's just the reality of sort of how my brain works, is that like next deadline first scheduling. It's not very effective, but it's close enough. But yeah, I try and spend like maybe a day's worth of work on the books each week. Sometimes I'm lucky enough and there's intersections with my job, and I can be like, oh, cool, we're gonna like figure out how to do this thing, and then I'm gonna write about it. And that happens not as often as I would like.
Yeah, it's writing a book is a fascinating journey. This is how many books did you write so far?
It's not a lot. Like I should know. Let me plug it into the computer. Sorry, the professor is very upset that there are people in the house who he does not know. So 1, 2, what's this one? Oh, okay, 3, 4. I'd say 4. Yes, 4 books. And from that, we could say that the Kubeflow book is the second worst book I've written.
Second worst? Why?
Or alternatively, like, maybe third best would be maybe a happier phrasing. But yeah, whatever. So I would say it's the second worst, mostly because I think that we did not pick the right time to write it. And that's just the reality of it. And so the concepts are all still super solid, but the first 2 chapters, which is, in my opinion, like normally where you like either get someone or you lose someone, they're out of date, and it's really unfortunate because the subsequent chapters are not bad, but the first 2 chapters, it's very much like, hey, here's how we get started with Kubeflow, but now how you get started with Kubeflow is very different, and so that's rough. But whatever, that's fine. The worst book / first book that I wrote was for Spark 0.7. And most of those APIs are still there because we're not very good at deprecating APIs inside of Spark, but like there are a lot of things which are a lot easier to do now in that book. Like literally everything in my first book that I've written now is already like, yeah, you could do this. You probably shouldn't, but you could. So like, yeah, oh God. That was back when like deploying it was like run these shell scripts and SSH. Oh God. Sorry. Memories.
That's all good. I think actually these books are the books that teaches us the history and the internals and how things evolve, so people can actually appreciate the tools that they have today. People that are now coming to Spark. I don't know, I think the project is 10 years old, maybe a little bit more.
Yeah, it's old. I don't know how old though. But yeah.
Oh, yeah. Well, I think around 13 years, if I'm not mistaken. But yeah, they can really appreciate the path and the journey that open source went through and evolving, and people such as yourself providing and contributing back and investing time into developing it to make it more friendly. I think it's crucial. And it's also some of the risks we take with writing books, right? Because it's going to change. And this is just the way it is. And that's all good. But it actually reminds me of the children's book that you're working on, where probably not a lot of things are going to change, right?
I hope not, right. So with the children's book, right, sort of what I've tried to focus on is things that are a little bit more sort of foundational, right? It's not, talking about interesting optimizations or, fun, weird things. If we want, I can share my screen quickly. But we can see sort of, here's some of the gnomes, a little bit of their adventure. Tea is an important part of distributed computing. I prefer coffee, but garden gnomes prefer tea. We talk about how they decide on a leader. We talk about writing things down on separate cards rather than a single piece of paper to talk about how we split things up. We talk about sort of how the work is split up between the different garden gnomes, similar to how we split up work between different computers. We talk about map side reductions without using the word map side reduction, because if you told me that, if you told me that when I was in university, I would have been like, what the hell are you talking about? And wandered away. We talk about garden gnomes falling asleep, which is also a computer crashes, and similar sort of concepts. And then, that's sort of the conceptual side. And then of course we show how these concepts translate into PySpark. But we don't talk about filter push down or things like that, because those are details that could change, and also fundamentally, you don't really need to understand them. Or at least, it's great if you do, but I think we don't need to teach children how filter pushdown is evaluated. If they're really interested in that, I'm sure they can go out and learn.
I think that's brilliant. It's really simplified some of the concept, and the gnomes getting tired and going to sleep is a fantastic analogy into, my machine just crashed because it lacks, there's an outage or something happens.
Yeah.
And now I
ran
need
out
to
of memory. EC2 spot prices spiked.
Yeah, the love of EC2. This is amazing. I'm definitely looking forward to it. So, publishers, children books publishers out there, please reach out to Holden. She has it almost done.
And if you're interested, and you're not a children's book publisher, but either way, and I need to update the image because this image is a little scary. But you can go to distributedcomputingforkids.com and look at the first draft of the gnomes. Oh no, it's not loading. Yeah, okay. This is the first draft, and the gnomes look a little more chemically induced than desired. But you can give me your email address, and I will selectively contact you in accordance with local regulation, and definitely not send you unsolicited commercial messages. But I will let you know when Distributed Computing for Kids is available, and we can go from there. And yes, sorry, I just have to push the book a little bit, because otherwise, who's going to read it? Professor Timbit isn't so good at reading.
100%. Right, let's talk about our last topic for today's conversation. I think it's a very interesting one because it speaks about data infrastructure and their impact and all the great books, Holden, you wrote and you write, and everything that's going to come next. So how do you see, like, what are some of the biggest pain points that we have in data infrastructure today?
Yeah. So I think there's a whole bunch of different things. I think metadata is something which continues to be, continues to evolve, and we continue to see more need for evolution there, right? So Iceberg, Delta Lake, lakeFS, we're continuing to see like a lot of really interesting development. I think tracking data over time, data lineage is definitely just like, there's a bunch of early tools. There's Marcus from the people who used to be at, what's that company, WeWork, and there's a lot of really interesting tools in this space. I think there's no clear solution here yet either, but I think it's pretty exciting. I think we'll see some really fascinating things come there. I think otherwise, like data quality tools also in general, there's some really interesting stuff coming. I think I signed an NDA about one of them, so I can't talk about that one, but I'm really excited. There's some really cool, soon-to-be open source tools. Actually, let me see if it's public. Oh, yeah, okay. Cool. It is. They posted a YouTube video 4 days ago, so I can't say too much. SodaCL from some of my friends also looks pretty interesting. It's a DSL for writing sort of assertions about your data, so you can have them evaluated when you go to save a new table, right? And it can be like, hey, what's up? We're not going to save these changes because all of the data is null. No. And you may think I'm joking, but I have caused a serious incident at a company that is one of the largest in the world by, I don't know if I can swear on this, screwing that up before. And yeah. So I'm excited to see more tooling around correctness and quality, in addition to more tooling around metadata tracking and data lineage tracking, because I like not causing production outages. It's one of my goals. Is your book an early release yet?
Yes, it is. I'm actually going to finish the 9th chapter, but there are 3 chapters out. Thank you. It's slowly progressing, switching jobs, and all this good stuff kind of postponed it a little bit. But it's slowly progressing, and I'm actually giving deadlines for myself.
So for people who have access to the O'Reilly Learning platform can get the early release copy of your book there, yeah?
Yes, and also there's a GitHub repo which holds all the coding samples, Jupyter notebooks, all the good stuff for people to try it out themselves.
Awesome.
Yeah. Cool. Wonderful. Well, I am super excited for your books. I am super excited for ecosystem, the fact that, you're creating more educational content for people to learn and kind of get better understanding of how real world problems are. So it's always fantastic to have that more information out there from experienced people such as yourself. Definitely looking forward to read it. If you're looking for reviewers, everyone at home listening to us, and me too, I'm always happy to take a look, provide some insights, ask good questions. And also if you're...
that.
Yeah, always. And also, people at home, if you're interested to learn or to read a little bit more about machine learning with Spark, things that are not the traditional machine learning, but actually goes beyond and speaks of the distributed architecture, etc., you're most welcome. More than happy to get your insights and questions as well.
Where should people reach out to you if they want to be an early reviewer of your book?
Yeah, so you're most welcome to reach out over Twitter. That's at Adipolak, ADIPOLAK. My DMs are forever and never open. I know this is a decision I made, I think 3 years ago, and I'm sticking to it. Yeah. So my DMs are forever and ever open. You're most welcome to come ask questions. I'll share all the GDocs with you, or PDFs, or whatever you prefer. And I'd love to get your insight and feedback. Holden, what about yourself? Where can people see the early release for you, for your books?
Yeah, similarly, it's in a weird hybrid of Google Docs and GitHub. If you're interested, my Twitter DMs are often open, occasionally closed. You can also just email me. It's just my first name dot my last name, so holden.karau@gmail.com. And I am always happy to chat with people about the different projects that I'm working on. And I would love more feedback. I think big shout out to everyone whoever is an early reviewer or gives early feedback on a book. Without you, technical books would not be nearly as good as they are. There's the reviewers for the Dask and Ray book, right? I was going through some of the comments last night, and without them, these books would just not end up nearly as good as they are. So thank you for taking the time if you're one of those people. And even just small fixes, those are valuable. So keep up the good work, y'all.
Yeah. All right. Thank you so much for listening. Today with me, we had Holden, and I am Adi, and we are hosting on the GOTO Book Club, and it was lovely to have you, Holden, together with me. So thank you, everyone.
It was really great catching up.
Subscribe to the GOTO YouTube channel now and join the experts in person or online at any upcoming GOTO conference using the promo code Book Club. Visit gotopia.tech to learn more.